Okay, I believe that we're live now and we're starting to record. So I'm gonna quick post this in Schoology for everybody, just as a reminder for pre-AP. And I've already posted a couple questions that I'm gonna answer. Give me just a moment to post this. Yeah. All right, comment all the classes. And then I'll start going through it. And if you guys come up with any other questions, we will address those. However, I would have to say that I feel like this could be a rather short one because there's only 7 questions in the test, 5 multiple choice, 2 free response. We only have 2 essential skills, and 1 of them we covered in class with Hess's law. So thermochemistry is one of those ones where we could go really deep. In an AP Chem, we would go really deep. And so we're trying to give you more foundation, more to build on. And maybe as time goes on, maybe we'll delve a little bit deeper into it in pre-AP. At the moment, it's not as deep, so could be pretty quick. All right, so let's just start answering questions. The first question is, how many different ways do we solve for delta H? So I'm going to share my Bamboo tablet. And we'll talk about delta H. Okay, so you know what? Let's make this blue because I just don't feel like red right now. Delta H equals enthalpy. All right. Enthalpy is usually the heat of a reaction. And I'm abbreviating reaction with RXN. Delta H is equal to the H of the products, the enthalpy of products, minus the H of the reactants. And as you get further and further into chemistry, you're going to find that it's a lot of products minus reactants or products over reactants. So this is one way that you would find delta H. Okay, you would put those together. And if we were going to expand off of this, one of the forms, we'll call it the forms of Hess's law or determining heats of reaction, is by doing the delta H of a reaction. Okay, and that's the overall delta H of the reaction, which is equal to the sum of N, which is the moles, times the H of the products, minus the sum of the number of moles, the coefficient, times the H of the reactants. Okay? So that's kind of an extension off of this. If you add up all of the H's, all of the enthalpies, the heats of all of your products, minus the heats of all of your reactants, you subtract them and then you can get the delta H of the reaction. Now, these H's are very specific. They are the H's of formation. Okay? And sometimes you can call them the delta H of formation. Now, delta H of formation is how you make it from constituent elements. And really, it's just the making of 1 mole. Or I shouldn't say forming. Be a lot easier. Formation of 1 mole, okay? So, you know, if we're gonna go really simple, we might say something like Na plus Cl2, and oh, we need to include the state symbol solid, plus Cl2, maybe we make it a gas, gives us, and you know what, I'm not gonna do the equilibrium stuff, it's probably gonna mess you up anyhow. Makes NaCl as a solid. Now, you might say, oh, we need to balance it by putting a 2 in front of the NaCl. No, it's the formation of 1 mole, which means that the way that we balance this is by putting a 1/2 in front of the Cl2. Because you're just making 1 mole, it's just 1 mole, okay? The same thing could be said for if you did H2 plus O2, and let's say these are both gases. And maybe we're making H2O as a liquid, okay? And if you do that, you want only 1 mole of that, so you're probably gonna do 1/2 in front of the O2 right there. You're making 1 mole, okay? All right, so that's the delta H of formation, which is then used so that, I'm gonna switch colors for this one. So these, right, it's 1 mole. So these right here are the delta H of formation, and the delta H of formation goes into here, which when you do, these are the delta H of formations of the products minus the delta H of formation of the reactants, and that gives you the delta H of the reaction, okay? And don't forget these N's, these are the coefficients on your actual balanced reaction, the actual reaction itself. Now, the reaction isn't necessarily forming 1 mole. You don't worry about that. The delta H of the reaction is whatever it gives you. And so the delta H of the reaction is always like a per mole. And oftentimes, sometimes it could just be straight kilojoules, or it could be kilojoules per mole as the units. The formation is always 1 mole. And so that one is usually, the units are usually kilojoules per mole for that, okay? So we have, if we're gonna, I mean, it's technically, it's still this one right here. This is still that one way, but there's like some subways to do it. There's the A way, which is just the reaction. There's the B way, which is the formation, okay? Now the C way of doing it, let's say, I'm gonna go to the next page. We're still doing products minus reactants, but maybe we're doing the delta H combustion, okay? It's still products minus reactants, which means that delta H of combustion is the same thing as delta H of the reaction. They are the same thing. It is still calculated the same way. The difference is the fact that delta H of combustion always ends up with whatever your substance is. Let me draw like this. Your C, it's a hydrocarbon, plus oxygen yields CO2 plus H2O. And this is an interesting one, because let's say you did something like C3H8 plus O2 yields CO2 plus H2O. And you might say, okay, well, I have 3 carbons, so you are balancing this. This is not the necessarily the formation one, but you're going to balance this. So I'm going to use red to make it a little more obvious. So there's 3 carbons here, so I'm going to put 3 carbons here. There are 8 hydrogens here, so I'm going to put a 4 here, 4 waters there. Now, this is key. There's 6 and 4, that makes 10, right? Wait, is that right? 6 and 4 is 10. Oh, this one works out really well. So you just put a 5 right here. But I should have picked a different one. That's okay. The point is it doesn't really matter what I put here, because we're going to ignore it entirely, because, oops, because the, let's say the delta H of formation of an element in its standard state is equal to 0 kilojoules per mole, okay? So you would just have a 0 there anyhow. So the thing I bring this up is because you would probably end up making fractions more often than not. Let me see if I can make a fraction. Maybe it has to be a C4H plus O2 yields CO2 plus, I bet you I have to do it like that. Let's see. Okay, so I give me 4 carbons here. I have 5 hydrogens there, so 5 plus 8 is 13. So to get to 13, I would have to do 13 halves. Okay, that still gives me just 1 mole of this. And then I can just ignore this entirely. So it doesn't really matter. It doesn't matter what the coefficient is because it's going to be 0. All right. So that's got to remember that all the time for that delta H of combustion. You need to write it out. You have it plus oxygen yields carbon dioxide plus water, and then you can solve that. Okay. So so we have, just as a reminder, we have our first way of doing it, products minus reactants, and we do it with this form right here with the delta H of reaction equals the sum of the products minus the sum of the reactants, and these are formation. You get formation by adding the elements, the constituent elements together in their elemental state. So your diatomic ones are diatomic, your metals are just solids, things like that. And then the last one you have is the last form of this products minus reactions is the delta H of combustion, which is the same thing as delta H of reaction. So you still have products minus reactants, okay? Which, you know what, why don't I just write out kind of what that would look like. That means that the delta H of combustion for this one is going to be equal to the products. So you have 4 times the delta H of formation of CO2 plus 5 times the delta H of formation of H2O, right? Minus the 1 times the delta H of formation of C4H10. And we're gonna actually, what we're gonna do is, you see that there's brackets there, right there, that's brackets, and you can put little parentheses around these 2 right here. And then I'm gonna put brackets around the backside, plus, and you'd have 13 halves times delta H of formation of O2. And of course, the key to that right there, which is really nice, we'll make this purple, lots of different colors today. That just goes away entirely. That's going to be 0. So you don't have to worry about that. Okay, so that's how you would set that up. Now, since we're talking about that, I think I have a worksheet open. Let me see if I can share that with you guys just real quick. It's one of the ones you actually did, but this would probably be a good time to look it over. So actually there's 2 of them. So why don't I show you the heats of reaction first. All right. So the heats of reaction, this is the delta H of reaction equals delta H of products minus delta H of reactants. Delta H of reaction and combustion are the same thing. So you have here, this is just a reaction, products, CO2 plus CaO minus the reactant CaCO3. And it gives you the numbers, and you can plug all those numbers in and solve for it. Pretty straightforward. Now, so again, you solve for the delta H of reaction is there. Okay, here's the delta H of combustion. Products minus reactants. And remember that the O2 is 0, so it's not even included down here. Okay. I would say this is where it gets tricky. So they say, given the heat of combustion, so that's the same thing as reaction, they actually give you the number right there. okay? Then the question says determine the heat of formation of propane. So now this is like algebra. The one you don't have, you're doing, because you're solving for propane, the one you don't have is this one over here. And you can see if you write the whole reaction right there, that propane is the one you do not have, the delta H formation of that. You have these other ones. So you plug in all those numbers and then you just isolate that one and solve for it, which is what you did here, okay? So, and here is, oh, this is the one I did. How funny is that? So this is the one I just did a second ago. I didn't have numbers for it. And this one is, again, you're talking the heat of formation of butane. And so you can see they give you the heat of combustion of butane, and then use the carbon dioxide and water, and you just solve for the formation of butane. Okay, so that's how you would solve that. Now, what I wanted to show you, since we're talking about this, the heat of formation. Let me open that one real quick. Okay, there we go. So, and I think I have the work here. Okay, so now you can see that the formation, you've got C plus O2 yields CO2. And really, I kind of prefer this way of writing it. Like this was the confusion. There was questions of, okay, well, how much energy is produced? Well, it's exothermic, so heat's on this side. So you get this energy. You don't produce a negative amount of energy. But if you have to label the delta H, it's exothermic. So the system loses that energy, which is why it's negative 393.5 kilojoules. The reason I prefer this is because this feels tricky to me. Sometimes they write it out like that's the reaction. That just feels tricky. So most often on the tests and things, it's not going to ask you how much did it produce. It might ask you what the delta H, or what's the heat of reaction or heat of formation or something like that, in which case you're going to have to give the negative if it's exothermic. Okay, so I'll try to avoid, I'll try to avoid making it tricky on you guys. So, but those are the reactions for formation for each of those. Now, so number 2, though, is kind of an interesting style of question, because it's asking you to say, okay, so if you have this delta H of formation of sulfur dioxide, how many kilojoules of energy would you get if you only had 25 grams? Well, see, the whole point is this is kilojoules per mole. So you got to figure out how many moles of SO2 there are, and then multiply it times the negative 297 to figure that out, okay, which is what we did here. And so you get that answer. That's fine. Is there anything else I want to talk about on this worksheet? No, that's fine. Okay. Now, what we haven't done is the last way of solving for delta H. So we've done 1, A, B, and C. Let me share the bamboo paper again. And the other one is the other essential skill, which is Hess's law. So what I'm going to do first is just talk about it, and then I'll get on to the next question, which is how do you approach it? How would you solve for those problems? So the second way of solving, let me change back to blue because I like blue. The second way of solving for delta H is Hess's law. Okay, so this is adding the delta H values from each step to get the delta H for the overall reaction. Okay, so that's all you're doing. If you've got some delta H's in between, you know that you're gonna have to add them up. Reactions are never just a single step. Well, I say that, I'm sorry, let me back up. They can be. They're infrequently a single step. Most likely they're made up of many multiple steps, but delta H is what's called a state function. And state functions don't care how you get there. They just want to know what the overall energy change was, okay? It's sort of like saying, you know, how far is it from here to, from Rockland, how far is it from Rockland to Roseville? And you would say, oh, it's 10 miles. Like it's just 10 miles straight there. That's the delta H. Now, to get to Roseville, let's say you drove, you know, first we're gonna go up to Auburn, and then we're gonna drive from Auburn all the way across to El Dorado Hills on 49 or whatever, and then come down to Folsom, and then we're gonna come all the way across Folsom into Roseville on Auburn Folsom Road. And so you took a long way to get there. Delta H doesn't care. Delta H is like, it's only 10 miles. You could have done that whole thing and gone all that crazy route, but it's only one step. So what we're learning is, hey, well, what were all those individual steps? The positives, the negatives, the whatever else, okay? So that's the purpose of Hess's law, is to if you had all the individual steps, what would the overall be though? What would the final one be? So that's adding delta H's. So it's not the products minus reactants. This delta H is the adding of those delta H's together. So that's the second way of doing it. So I thought that this would be where I would end that question and actually begin the second question, which was, how do we approach Hess's law? I think Hess's law kind of gave people a hard time. So I'm going to go through the second, I put up a second Hess's law worksheet. And so some of you may have done it, some of you may not have. But thought I would go through it, and you would have an opportunity to see how I break that down. Let's share that actually. There it is. Okay. Kind of fun. Here's the Hess's law worksheet, and we have the key too. It's the key is attached to the end of this. So what I'm going to do first is I'm going to show you this, and while you're looking at it and trying to figure out, I'm going to go ahead and write these things down, and then switch to my bamboo paper, and we will solve it on the bamboo paper, and then come back, and then I can do the next one or two on there by not going back to the bamboo paper, because this is a lot to write down. So just give me a second to write this down. And remember that states do matter, especially if they're the same substance in different states. That absolutely matters. Okay. Oh, shoot. Sorry. This is, I guess I didn't think this through all the way. This is taking, this is going to take a little longer than it. Not a good use of time. C2H4 gas. Plus 3. See if you can figure it out while I'm doing it, right? You know what's really awful is that my handwriting is so bad on this that you guys are hardly going to be able to tell what I've got going on. All right, I think I've almost finished it. This is torturous waiting for the, I'm so sorry. Okay, ugh, hand cramp. Okay, let's try this again. Okay, so let's do this real quick. Okay, so it's probably not very easy to read, but we have a final equation. So step one, I always make step one the writing of the final equation down at the bottom, okay? So you know what you need to get to. The second step is finding the solo substances. So you need to find the thing that's the same, or that's only in that step and not in the other steps, okay? So for example, we've got C2H4. Is C2H4 in the other equations? This one right here. And the answer is no, I don't see it in these other ones. So that's my first equation. And I would say that looking at it, there's a C2H4 in the final equation, so it's on the correct side. So I'm not flipping this reaction. So C2H4 plus 3O2 yields 2CO2 plus 2H2O. And the delta H is negative 1411 kilojoules. Okay, great. The second one, I've got C2H6 right here. Is that in the other two? And I would say no. And I would say, but it's on the product side. So what I'm going to have to do is I'm going to have to flip this reaction. So I'm going to rewrite this. And what that will look like is, actually I'm going to make it red so that you know that I flipped it. So I have 2 CO2 as a gas plus 3 H2O as a liquid yields C2H6 as a gas plus 3.5 O2 as a gas. Now, when I do that, I flip the reaction. So now I need to change the sign on my delta H. My delta H is now equal to, it was negative 1560, now it's positive 1560 kilojoules, okay? All right, let's look at the last one. H2 plus half O2 yields H2O. Do I have H2 in the other two? Is there an H2 up here? No, wow, there's no H2, so interesting. So the H2 is down here, there's not another one else, it's not gonna cancel out, it's in the final one, it's on the reactant side. It's on the reactant side in the step, and it's on the reactant side of the final reaction. So I am good. This is how it should be. Now, do we need to multiply by 2 or divide by anything to get these to cancel out? So let me take a look at them. I'm going to switch to a brighter color to cancel out. Let's go with green. I think it'd be pretty obvious. I've got 2 CO2s here and 2 CO2s there. They cancel out. I have 3 waters right here, and I have 1 water there and 2 waters there, and they are liquids, so that actually cancels out. So the 3 waters and the water 1 and 2, that makes 3, so those cancel out. I have a 3O2 here, I have 3.5 there, and then a half right here, so 3.5 and 3.5, so those cancel out, half and half. So I have C2H4, C2H4, I have H2, H2, C2H6, C2H6. So I can just add these together. Actually, that was pretty easy. Let me just grab my calculator. And let's see, so I've got negative 1411 plus positive 1560 plus negative 285.8. And the answer that I come up with, okay, this was, I'm sorry, the last step here, I didn't mention, is the adding and canceling. I meant to mention that. The last step, third step, is add and cancel. So I canceled out the things that are the same on both sides and I added them together to get to the right thing. And that's where you multiply and divide. So my delta H for the whole thing was equal to negative 136.8 kilojoules, okay? So now that I have that answer, I'm gonna go down, I'm gonna go back to Hess's law and get off the bamboo paper, which has gotta be driving you guys nuts because it's driving me nuts. And go to the Hess's law worksheet. And for number 1, we had only flipped the second one right there. And then you add them together and you get negative 137. Perfect. Okay, good. Okay, the second one, we just look right on here. Our final reaction is this right here. It's got to be 4NH3 plus 5O2 yields 4NO plus 6H2O. So I write that thing first, and then I would look at each reaction, look for this solo thing, the thing that it's not in the others. So N2 is right here, so you can't do that one. O2 is right there, so you can't do that one. 2NO is not on the other one, so that's perfect. So I've got NO here, and in the final reaction, it's also on the product side, but there's 4 of them, and there's only 2 here. So I'm gonna leave this reaction as it is, but I am going to double this one times 2, which means this delta H is also gonna be multiplied times 2. So you're gonna get negative 361. And then the second reaction, the N2 we already talked about, the H2 is right down here, the NH3, NH3 is right there. It's not in the other 2 reactions, but it's on the other side here. You can see it's on the reactant side here, and here it's on the product side. So we're gonna have to flip it, and it's 4NH3, and this is only 2. So we're gonna have to flip it and multiply it by 2. So it's gonna be positive 183.6 or 16, I don't know, something like that. Okay, the final one, the H2 is right here. The O2 is right there, and the H2O is, there isn't H2O. This is good, okay. So then it's a product here, and it's a product. So I'm actually leaving it as is. I'm not having to flip it, but this is 2H2O. That is 6H2O. I'm gonna have to multiply this one times 3, which means this is gonna be like negative 1,200 or 1,300, something like that. So we've got 1,300 plus a positive 180 plus a negative 360. So I think that's gonna make it like negative 14 or something like that. Oh, 16, look at that. So we times it by 2, we flipped it and multiplied it by 2, and the bottom one multiplied times 3, negative 1,600 about. That feels about right. So hopefully you guys are on the right track and you're kind of getting this. And again, this second worksheet is great because it breaks it down exactly what you do to each step, so you can see how you should be solving it. So hopefully you're getting the hang of that now. So that's Hess's law. So we've actually covered both essential skills with those first 2 questions. And I see that I have a question from Zarina. So I'm done with the last question. Next question. Could you please go over number 3 on the enthalpy of formation worksheet? So let's share that one. Enthalpy of formation, number 3. There we go, number 3. The heat of reaction for the combustion of 1 mole of ethyl alcohol is negative 9.5 times 10 to the second kilojoules. So now that means that this is the delta H, right? I can type it in here because it doesn't really matter. This is the delta H. And it's negative because it's delta H. When you look down here, that means it's exothermic, heat's a product. So when you write the reaction here, they wrote plus 9.5 times 10 to the second, okay? So that is just that other way of doing it. Remember, this is not my favorite way of doing it, but this is also a way that you could show the amount of energy produced by the reaction. So we have combustion of a mole of ethyl alcohol. So how much heat is produced when 11.5 grams of alcohol is burned? Okay, we can do that. Because this right here is the amount of energy, that's kilojoules, that's in the combustion of 1 mole. There's a 1 in front of this ethanol right there. All right, so what I'm gonna do is, now that you guys have seen this reaction, I'm gonna go ahead and share my Bamboo paper, and I'm just gonna go through how to solve this. Okay. So we had back to blue, C2H5OH, and its delta H was equal to negative 9.50 times 10 to the squared kilojoules, Or you could say it's plus 9.5 times 10 squared kilojoules produced, right? Okay, so just a way of another saying it. So now we're going to say, okay, we have 11.5 grams. So 11.5 grams of the ethanol, which is C2H5OH. So since this right here is actually kilojoules, that's actually kilojoules per mole. Kilojoules per mole. Because it's produced in 1 mole. So if we have 11.5 grams, how many moles is that? So what I have to do is take this and divide it by the molar mass. 2 carbons, that's, well, I could probably just do my calculator. So 12.01 times 2 plus 1.01 times 5 plus 16 plus 1.01. And I get 46.08. 08 grams of C2H5OH in 1 mole of C2H5OH, okay? So when I do 11.5 divided by that, I get equals 0.2495. Doesn't really matter because this isn't our final answer, but I'm gonna round it right there. Moles of C2H5OH, okay? That gives me the number of moles. Now, if I want to know how much heat is produced, which is just straight up kilojoules, I'm going to take my 9.5 times 10 to the second kilojoules per mole times 0.24957 moles, right, of the C2H5OH. The moles right here will cancel and multiply those two together times and the answer is 237.09 kilojoules produced. Okay. Now this one is because 11.5 is our measurement that was given to us, 3 sig figs, 1, 2, 3. So the answer is actually 237 kilojoules produced. Okay, and so what's going to happen is you'll notice that I say it like that, so that's a positive. Okay, or you could say if you were just given that much, the delta H, well, see, it might be hard, but you'd say maybe the delta H is equal to negative 237. But again, this is back to where I'm not going to be super tricky on you. I'm not going to give it to you. Oh, is it positive 237 or negative 237? Like, I don't think that's very nice. So you guys will be fine. Just that's how you would calculate that. Okay. Okay. So that ends that question from Sabrina. Thank you very much, Sabrina. Let me see if there's anything else I was thinking about covering. If you guys have a question, though, I'd say put it up there. But again, it's a short test. So it's 11 points total. The 5 multiple choice are each worth 1, and then the free response are worth, one of them is worth 4 points. The Hess's Law one's worth 4 points, and the enthalpy of reaction one is worth 2 points. But I don't have anything else, I suppose. It's sort of a short one, but I want to make sure I got one up there. I know some people are interested in watching this. So, are there any other questions? No questions? Okay. Well, if there aren't any other questions, I'm going to go wrap this up. You know that you can come in and find me and ask questions. I'll be around. I would say this, Friday morning, I will not be available because the soccer teams are having a breakfast. So I'm going to start making those announcements in my classes. You cannot come in Friday, not Friday morning for help or to take the test in my room. I don't know what time Miss DeMaria will be there, but Friday morning will not work. Thursday at plus, Thursday at Plus, I have a Science Olympiad, or no, Thursday at lunch. Thursday at lunch, I have a Science Olympiad meeting, so you want to come in during Plus. Friday at Plus, I'm doing a review session. So maybe in DeMaria's room, you could be doing it, or you could be doing it at the lunch part. The Plus part will be working, the lunch part you can come in. It shouldn't take you more than a half an hour. So I would strongly encourage you maybe before school on Wednesday or Thursday, or you could do it after school, I think. I think I'll be around for this. I see I have a question from Holly. How do you find the heats of, okay, so let's post that out. How do you find the heats of formation reaction for CuCl2? I couldn't find it in the textbook. That's the formation worksheet number 1. Okay, let's share that one and take a look at it. Okay, so of the CuCl2, was it not in the, here? It's just like that. You, oh, you're saying you couldn't find a place to put it. Okay, oh, finding the delta H. Okay, I will say this. We said to look it up. You could, I think the direction said, what did the direction say? So it gave a couple examples, page 896 and 902. I'm sorry if that was not in there. I would say that you can, the actual delta H value, if it's on the test, obviously we're going to provide it for you. Let's see. And of course, we gave you some of this. I mean, I gave you some of the answers here. Oh, this is, these two right here didn't, they both were CuCl2s, and they shouldn't have been, they should have just been CuCl. But anyways, if it's on the test, the main thing is that you know how to write. You can write the reaction without looking it up. The delta H value probably was harder to find. I apologize if I sent you on quite the chase. You can just look it up. You could have just you could Google it. What's the enthalpy of formation of CuCl, and it would give you the delta H value. But on the test, we'll provide you any of that. We're going to provide you with some tables that have the information. In fact, let me look and see if one of our, this is one of the, no, I don't, on the worksheets. Okay, so I'll just tell you that there are questions that refer to a table, and we provide you a table in the middle of the test. It's a big table with like 20 different substances, and you would refer to that to get information. So that's how you would do that on the test. Okay. All right, good question. Any other questions? It doesn't look like it. Looks like everybody's gone. Okay, well, in that case, I bid you all adieu and good night and get some rest. And I will see you for the test pretty soon. Thanks a lot.